new channel. I'm Brandon. I'm going to be talking to you about solar storms today. Um, so as most of you know, yesterday there was a solar storm, and I figured why not talk about what solar storms are, since you see it all around the news and you probably have no clue what it's all about. So this video is going to be talking about what solar storms are. Solar storms are eruptions from the sun. They are the sun undergoes an 11-year cycle where every 11 years there's a brief period of calmness. Then towards the middle of the 11-year period there's a period of activity, I guess is the best word to describe it. Anyways, between the years 2010 and 2013, right now we're currently in the middle of this period of activity where we see solar storms pretty darn often. So what is a solar storm? A solar storm is when charged particles from the sun, also known as plasma, gets shot out from the sun and causes a huge burst of radiation. And the solar storms that are of most interest to scientists on Earth and people on Earth in general are those that are pointed directly to the Earth. And the most famous example is the Carrington event in 1859, observed by Richard Carrington. He noticed that there was a lot of activity going on with the sunspots on the sun, and he noticed an ejection of particles coming out of that sunspot. And the ejection was heading straight towards Earth. Now, this ejection is called a coronal mass ejection, or a CME. That's what I'm going to call it from this point on. And CMEs, as I mentioned earlier, are when charged particles are being spewed out from the sun at millions of miles an hour. And during this Carrington event, telegraph systems in Europe and America had failed, even though some messages were continuing to be sent even after the power was lost. And the most recent example of a CME causing electrical problems was the 1989 geomagnetic storm affecting the Quebec area. The Hydro-Quebec's electricity transmission system was destroyed, causing a huge blackout in Quebec and also causing auroras to reach down as far south as Texas. Now, auroras. What are they? As some of you may know, auroras happen when charged particles excite the gases in the atmosphere, nitrogen, oxygen, what have you. And the different colors happen when the light reflects off these different particles. So we see different colors like red, green, purple, so on and so forth. And as a result of these interactions between the charged particles and the gases in the atmosphere, we see an aurora borealis, which it's the northern lights, and aurora australis, which is the southern lights. Now onto biological systems. Some of you may think that, oh, we're getting hit by particles spit out by the sun at millions of miles an hour. We're probably going to have something wrong. So something's probably going to hurt biological systems. No, not the case, typically. Because of the magnetic field in the atmosphere, we are safe from the radiation effects from the sun. However, if there was an astronaut in space, he'd have to be wearing special equipment to be protected from the radiation, because the amount of radiation being spewed out by the sun is well beyond the toxic limit. So typically the concentrations that you see from the sun will kill an astronaut in space. Despite this, there's still a chance that while biological systems aren't affected, power grids, satellites, GPS, etc., radio can be affected. And in severe solar storms, we could see potential blackouts for months at a time. That's basically what a solar storm is in a nutshell. Feel free to ask any questions in the comment section below and regarding either solar storms, CMEs, or anything in science that you'd like to see talked about in future episodes. So, subscribe, comment on the video below. I think I covered all the bases, so I hope you enjoyed the first video, and I hope to see you back here again soon when I upload my next video. Goodbye.